Before everything starts, the designer will model the manufacturing part on the Fusion 360. Once approved by the supervisor, the designer will work on the milling or turning of the Fusion 360 as well. As most people know, the CNC machine can run as we expected is because the machine implements the G-code. Due to the complex of product geometry, it is almost impossible to code manually. Therefore, the designer will use the Fusion 360 to arrange or order the process to make the CNC machine work smoothly. Moreover, the process can be run as a simulation to check if any crash happens. After the designer completes the machine or turning manufacturing space of Fusion 360, the G-code can be exported from the post-process, which will include an NC file. Then transferring this NC file to the CNC machine, it will run the G-code to mill or turn the part. Now we come down to manufacturing the pawn pieces for the chess set. To do that, the raw aluminum bar with 1 inch in diameter will be the material for the process. Firstly, the operator measures the diameter of the bar to make sure the material is within specification. After that, the operator put the aluminum bar into the Mazak machine. The bar is being held in a chunk of the machine solid to make sure there's no movement during the process, which can cause crashing. Then the operator will run the G-code, which was generated before on Fusion 360 and ran with the graphic mode for the final check. Before running the code, the operator will use the measuring gauge to measure the extruder part of the aluminum bar and let the extruder part is in design length. Finally, the operator will turn on the Mazak machine and always put the hand on the stop button during the process to stop it anytime when it's necessary. Cutting oil will be necessary during the turning on the lathe to reduce the heat of the cutter, as well as avoiding the tool head getting dull. The process takes about 10 minutes long to manufacture 1 pawn pieces. When the cutting process is finished, the pawn will be left for a few minutes to cool off the heat, and the operator will take it out of the lathe machine and do the final measurement. Milling. The design and programming code of all chess sets were provided by the instructor. The only work done by the students was to manufacture them. After all pieces' first operation were done, the students, with the help of the instructor, has set up the HAS VF-2 for second operation for most of the part and third operation for bishop piece. The operation consists of removing the leftover part from the first operation and having 2 holes of 0.188 inch diameter and 0.500 inch height placed at the bottom of each piece. For this operation, most of the pieces, if not all, were milled in less than a minute. The bishop slot was made as a second operation using the HAS TM-1 machine. Finishing. For machining the base of the chess pieces, HAS will be used for the process. First, the operator loosens the chuck on the HAS with a wrench and installs the chess pieces into the chuck holder. The operator will then use a 16 foot-pound torque wrench to tighten the chuck with a given force on the wrench so not to over-torque the part. After that, the door is closed on the HAS and the generated G-code is run. The milling pips will take around 2 minutes each single chess piece. Finally, after the process is done, the operator will take the chess piece out and clean it and do the final check on the base to make sure the part is within specification. Before the powder coating process, a filing is used to clean out any sharp edges. The operator will use the file to file any visible sharp edges on any single chess piece as a final check, since it will not be able to do this after the powder coating process. Carefully check on the slots of the bishops as well as the slots on the rooks. These slots can maintain the sharp edges after the turning operation. After that, all parts needed for a whole chess set will be cleaned with acetone. The operator will use a small brush to brush the surface of the chess pieces and cover up the surface till it is shining. After that, just let the part dry out and ready the powder coating process. After drying out all the part, the operator will take the pieces to the powder coating booth and powder coat the part. We can pick any desired color, but the classic color that the Falcon Patrol will use is black and white. To powder coat, the operator will use a spray gun and send away from the part about 10 inches. After powder coating, the use of UV light for the making check to make sure there is no spot on the pieces being left behind without powder layer. The part will be in the oven for about 40 minutes long with the temperature around 450 degrees Fahrenheit. Finally, the part will be taken out of the oven and cool it with the cool water and clean all the soft towel to avoid scratch or dent on the part. This fills will be added to the base to maintain the bottom of the pieces. Laser cut board. With the chess pieces completed, the next step of the manufacturing process was to laser cut the chess board. This began by creating the design on AutoCAD and choosing the desired pattern. Then material was loaded into the laser cutter and the homing and work offsets of the machines were updated. The correct feed and intensity of the laser was also selected, according to the machine's manual. After this, the program was uploaded to the laser cutter and the cycle was started. Depending on the complexity of the chosen pattern, the average cycle time for the runs ranged from 12 to 20 minutes. The engraving pass came first, where the details of the chessboard were lightly etched into the surface. Once this was completed, a final parting pass was made around the outside of the board to cut it free from the rest of the material. The board came off the machine completed, and the only finishing required was to wipe the laser dust from the surface.